I'm here with Nico, and I guess Misha's decided to join us. Well, in any case, in this video, we're going to talk about operations on functions. What, are you getting ready for surgery? Not those kinds of operations, mathematical operations on functions. Right, Misha? The concepts we will use in this lesson include adding, subtracting, multiplying, and dividing expressions. We will also learn to evaluate functions for values of x. Well, we already know how to do that, because that was a long time ago, right? Here we are. We are performing operations on functions. Now here we have two functions, and we're going to go through the operations. First, let's add the two functions. So we're going to say f plus g of x. That means we're just going to say f of x plus g of x. Well, let's add those two functions. It's pretty easy. Here we go. 3x minus 12 plus x squared minus 3x minus 4. Well, we just added two functions, and now really all we have to do is combine like terms. Oh, we got an x squared here. We have a 3x minus 3x. Oh, those just go away. And then negative 12 minus 4 is x squared minus 16. That's a perfectly acceptable answer after you've added the functions. Well, what if we wanted to subtract these functions? Let's say we're going to take f minus g of x. Well, that's f of x minus g of x. So let's do that, but let's be careful because we're going to need to keep our parentheses for this one. 3x minus 12, that's f of x, minus x squared minus 3x minus 4. And when we subtract an entire quantity, we might want to remember to distribute that negative. And really what that does is it changes the sign of everything after this subtraction. So let's do it. 3x minus 12 minus x squared plus 3x plus 4. Let's do some combining of like terms. Here we go. Negative x squared. Got that one done. 3x plus 3x is plus 6x. And negative 12 plus 4 is a negative 8. We have just subtracted g of x from f of x. You want to multiply the functions? So we're going to take 3x minus 12, and we're going to multiply it by x squared minus 3x minus 4. Now this is where we have to distribute. We distribute the 3 to every term, and then we distribute the negative 12 to every term. So we'll just do that. 3x times x squared is 3x cubed. 3x times negative 3x, negative 9x squared. And 3x times negative 4 is negative 12x. Let's just keep on going, and we're going to get a long line of terms that we can later combine. So let's do this. Negative 12 times x squared is minus 12x squared. Then we've got negative 12 times negative 3x is a plus 36x. And negative 12 times negative 4 is plus 48. We've got this long, seemingly daunting expression, but really it's not, because all we have to do is be very careful and combine the like terms. I'm just going to say, okay, 3x cubed, only one of them, 3x cubed, done. Okay, negative 9x squared minus 12x squared is a negative 21x squared. Done with the x squareds. Negative 12x plus 36x. Oh, that gives me a plus 24x. Boom, boom, and a plus 48. Done. Well, we've done add, subtract, multiply. Might as well do divide. So here we go. F over, or F divided by G of x is f of x divided by G of x. This one takes a little bit of ingenuity and maybe some factoring. So let's do it. F of x, 3x minus 12 over x squared minus 3x minus 4. Let's factor these and see if there's any of the factors that we can cancel with the numerator and denominator. So let's do it. 3, greatest common factor. I can pull a 3 out of both of those expressions, and that gives me 3 times x minus 4 in the numerator. All I did was factor the numerator. And now let's factor that denominator. We don't want to be scared of that trinomial. We got what multiplies to get a negative 4 and adds to get a negative 3. That would be x minus 4 times x plus 1. Little mental math to check ourselves. And guess what? We have a couple of terms we can cancel. X minus 4, x minus 4. And so f of x divided by g of x in this situation is 3 over x plus 1. Are there any restrictions on that denominator? Sure are. X cannot be negative 1. Now look at this little interesting mathematical symbol. That's not a multiplication, that's a small open circle. And guess what that is? That means this is a composition of functions. We're having two functions, f and g. We're using the output or the result of one function, and we're inserting it into the other function. So this is a great operation on functions, and I love this one. We're going to do an example and look at how two functions join together. Here's a great example on the composition of two functions. So we have f of x equals 3x plus 1, and g of x equals x cubed. And we are being asked to find f of g of 2. So I'm going to rewrite that, and just to get used to doing that, if I see it in this way, I know that I'm going to write f first of g of 2. And that might help us see it better. We're going to find f of g of 2. We're going to find g of 2 first, use the result from g of 2, and then find f of whatever that result was. Now, g of 2 means we want to plug g of x is 2. We want to plug 2 into the g of x formula. So we'll say g of 2 equals 2 cubed. And we all know from experience that 2 cubed equals 8. So I've done the first part. G of 2 equals 8. That's in the parentheses. So really, if we want to find f of g of 2, we're taking the result or the output from g of 2, and we're plugging it right on in to the f of what? Okay, so we've got f of, now we can find f of, well, what was g of 2? 8. And we can use the f of x function to find f of 8. So here we go. 3 times 8 plus 1, f of 8 is 25. So really what that means is f of g of 2 is 25. Pretty good stuff.
You're a popular kid around here, aren't you, Nico?
Now here's one more example on composition of functions that I really feel compelled to teach you because it's a little different than the previous examples. And just to start us off, we say we have f of x equals 3x plus 1, a g of x equals 2x, and we want to find f of g of x. Now in the previous examples we had numbers here and we could get the result of one and plug it into the other, but here we just have an x. That's okay. We're still able to find f of g of x. So here we go. I'm going to start with my f of x and I'm going to say 3. But instead, when I get to the x, instead of writing x, I'm going to write parentheses and I'm going to write my g of x, which is 2x. 3 times 2x plus 1. Ooh, can I simplify? Oh yeah. F of g of x equals 6x plus 1, and that's my answer. Pretty easy. Check this out. We've got two functions, f of x and g of x, and we want to find g of f of x. Well, that means we want to find g of f of x. Well, that's great because now I know I'm going to start at my g of x function, and every time that I get to an x in the function, I'm going to substitute the entire f of x equation. Let's do it. G of x is 2x, so I'm going to put 2, but instead of writing an x, I'm going to put in parentheses 3x plus 1. I'm inserting the f of x function into g of x. Well, that's pretty easy from here on out because all you have to do is distribute. And so my g of f of x is 6x plus 2. Here we are with the U-try. Remember, pause the video, try all of the problems, and then watch the quick solve. Have fun.
Thanks for helping, Nico. And thanks for helping, Misha. And thanks for watching.